So, hi Ben, what was your first computer?
So my first computer, I would say probably the first computer I learned on was an old Tandy Trash 80. So
Okay,
that was my brother's computer when I was growing up. He had a TRS 80, so that was um, I think it was one of those Z80 old kind of DOS
okay,
machines. I
okay.
don't remember too much other than I was little. I was very little, and he used to tell us that if we push the big red power button, it would blow up, so we couldn't push that button. And so you try to scare me, myself, my sister, little 5-year-olds or something
Okay,
like
and what
that.
was the red button? It was a power button, or what was it?
Yeah, yeah,
Okay,
with the power button.
okay.
So I think he just didn't want us to screw up his homework or something like that. So he used to tell us it would explode.
Yeah, it was a effective strategy actually. And
Yeah,
and
it
you
worked pretty
started
well.
you played games obviously at the beginning, right?
Yeah, I mean, I think I learned to read on an old game called Reader Rabbit on my father's 287.
Okay.
So, and then of course, games my brother had and a bunch of the old DOS World games, which were pretty fun.
And in one point of time you started programming, or you spent time with, I don't know, scripting, or what was your road to something not gaming?
I think I always wanted to. Originally I wanted to do hardware, so I was more interested in how I kind of viewed it like microprocessors. You kind of like a sandbox. Every
Okay.
18 months at the time,
Hmm.
it would double, and so you had more. You could build a better sandcastle. I
Hmm.
mean, and silicon is sand, so it kind of made sense. So I was very interested in the hardware aspect for a long time. I did learn to program, Pascal, back in I think junior high and high school, um, and then a little bit of C++ and other things on Turbo C and the like. But originally I was interested in hardware, and so I went kind of in that direction. But I did dual because I wasn't sure which way I prefer in the end. So I did dual computer science, computer engineering, and ended up that
As a kid, it was TRS. So I think you played games, and then what?
I'm
Then you got
I'm
another
sure I did.
computer and played more games, or in one point of time you started, to investigate it, what is actually programming, or what was the transition from gaming to hardware, or from gaming to programming?
It would more I would more oriented towards the hardware. So, I'd build the computers and those type of things, and then of course play games like Star Control or other random ones a lot. And but I think I guess I kind of did both in terms of building assembly computers and interested in kind of learning about more the hardware side more prior to college, and then also we my school started to have actual programming classes. So I was
Okay.
pretty kind of early, and so I took those classes to do like we did Pascal back in those days. And so I did that. But then when I went to school, I did both computer science and electrical engineering, and ended up just waited till I was graduating to figure out which one I'd be applying for on the
Okay.
job wise.
And for whom you build the computers, for yourself, or you sold them, or what you did with the computers?
No, I didn't really do much on the selling side. I would just build it for myself or with friends, and you'd read the old computer magazines to go through and try to see what the latest hardware was, and read Maximum and others to see, to understand about the latest CPUs or how
Yeah, yeah.
that stuff was working. And then we do things like a friend and I would trying to figure out how to. Back in those days, you might remember everything got hot very quickly.
Yeah.
Hard drives, you bought a SCSI, and they were just burned up, and you have to constantly fight with cooling. So friends and I would experiment trying to build water cooling systems from scratch, or we tried to figure out how to use a thermal pad in order to kind of blow in cold air and blow out hot air.
Oh,
If you remember those thermal pads, yeah, remember those thermal pads. Basically, if you put electricity to them, one side gets really hot, one side gets really cold,
okay.
and so we
Okay.
were trying to figure out how to use that in order to kind of cool down our machines, because our desktops are sound like a jet engine. Once you put in a SCSI drive or two, you had to put in a those old Pentium Pro heat sinks right on your hard drive just to cool it down.
Yeah.
Because the hard drive would get so hot it would die.
I,
So
I did
the
also my
cooling thing.
experiments exactly like you. What I remember, I built once a machine for me. It was a workstation with water cooling, and it
Mhm.
was, I think, Thermaltake. I don't know whether you know the company Thermaltake.
I remember hearing about
Yeah,
them.
and they had a rocket from
Oh,
it
cool.
was aluminium or steel, or a rocket with the water just flew to the rocket up, and then like a waterfall was went down, and there was a small pump in the computer. It was around 2003. This was the hardware I'm talking about. And with the rocket, it came an yellow fluid, which glue in the dark or something like this.
Oh, yeah, I saw that. Yeah.
Yeah, and the problem was, so I assembled my computer on the desk, and the fluid reacted with the sun, which I didn't knew. And the pressure built up, and the entire thing blew up, and the yellow, yellow fluid just, exploded on my ceiling. And until now, there is a patch. And until now, I said it was a really funny situation because I assembled, all the pieces. And at one point of time, the pressure built up. I couldn't do nothing against that. And then I read somewhere that actually the fluid reacts with the sunlight.
Yeah, I didn't try to do colored fluids. I thought those and neon lights and things like that people were putting on pretty neat. I think at one point when I was in college, I ended up buying one of those machines. I don't know if it was that brand, but I remember buying one of the popular water cooling brands because I just didn't want to have to build it again. And it was pretty nice. I mean, it kept everything very quiet. You could buy
very
the
quiet.
Specialized
it was very quiet. Yeah.
Like that. And I mean, before that, I mean, it just like I said, it sounded like a jet engine once you had a powerful computer because it was just so loud, trying to keep everything somewhat cool.
Yeah, but recently I bought another thermaltake chassis, and this is extremely quiet. It was actually not my intention because actually a server, but it was extremely quiet. Also, it has several fans. But they are huge fans, and they're from Austin company. I don't know whether you're aware of it. It's called Noctua, so it's just very, very silent. Yeah, interesting. So you started computer science?
Yeah, I mean, I did computer science, computer engineering for school. Just basically, that was a dual track. The computer engineering is basically electrical, but you would just swap out a couple classes for more digital logic.
Okay.
And so I just did the dual because I wasn't sure which way I liked. I liked the hardware, but I wasn't sure if sometimes you just have more Inuit skill, and so the CS side stuff just always clicked, and hardware was always a little bit hard to try to work through for me.
Okay, and when you learned programming?
Oh, I learned, like I said, I learned programming. At least more formally, I guess, would have been in high school, and probably bits and pieces I learned earlier, but nothing major. I wasn't doing a lot. I mean, I mostly, if I was doing something, it was like trying to hack Doom in the hex editor to increase my life. Back when you get to do that on your save game files,
okay.
Those type of things. But nothing, other friends of mine would program their TI calculators and BASIC and do that type of stuff, and I just never, I never got too deep into it before doing more college, and then I did the bits and pieces from classes. But
so you were more or less forced to learn programming, right?
I was interested in it, but I wasn't interested in it from a perspective of building games.
Okay.
I was more interested in it from the pure engineering side of things. So so I really love freshman year when you take the data structure class,
okay.
and it's when you start learning about trees and hash tables, and then later when you take your algorithms class, I thought that stuff was very fun and interesting. So
okay.
The games would always just it's a fun excuse to be on the computer, but I was more interested in the engineering side of things, of how it works and how you build it and how you design something, and that's where starting out, I thought that from a hardware perspective, I liked that side, and then learning from college, the actual software engineering side, which at the time I didn't know very much about. So that's why the software programming, it didn't really draw me too heavily at the time.
And where you studied? Which university was it? You know it?
Yeah, I went to a school called Illinois Tech in Chicago.
Okay.
I grew up in the Bay Area.
Okay.
And at the time, I just wanted to get away from California, and so I went to Chicago. It was a good school, good scholarship, and then I came right back to California because I learned what winter was like, and snow and wind, and everything about Chicago, which I naively did not know much about at the time.
And you like the proper winter and snow, or you prefer the Californian climate?
It's nice to experience, but it's California is a lot better. I would definitely not having definitely prefer California overall. So go a couple years out and you learn to appreciate home.
Yeah. So what you learned? Which programming languages you learned during your study? So university, was it C, C++, Java?
Yeah, we did mostly C++ and Java at the time. And I mean, since I was doing a lot of hardware, I mean, lots and lots of assembly and HDLs, so like 3 or 4 different hardware description languages.
Hmm.
Um, and yeah, but like yeah, there wasn't a big push on the language side. It was just use whatever language you want, and that
Okay.
was either we started with C++, and then people would use Java, but it wasn't. They didn't really push any perspective on that.
What you did in your leisure with this stuff? Could you do something? Let's say, I don't know, create your own hardware or whatever, or was it just you couldn't do something like this? Because so I studied computer science on site.
Hmm.
On my leisure, I always created something just for me, hack some stuff around. I played with programming. I did a lot of C, C++, Java. Is something possible in on the hardware side? So you did something hackery?
You could. You could a little bit, but it was kind of hard because you're spending your time on breadboards and
Yeah.
you're programming the various chips, FPGAs and the like. So you could. Honestly, at the time, I kind of figured that you only have like one time for going to college,
Okay.
university. It's like, or mostly you only have like most people only have one shot to really spend a couple years. So I just decided I would try to cram as much as I could. So I didn't do a lot of hobby projects on the side. Because I did 2 degrees and a master's. I just crammed it all in while I had
Wow.
scholarship.
Okay.
And so basically, I know, and do that, took my summers and everything else. Um, so I was, so I just didn't do as much hacking, which is unfortunate, but would have been fun to do. But I just didn't
Wow.
do it much because I
So
just
you were
tried
really
to cram.
focused student, right? So incredible.
Yeah, I mean, that was what I tried to do. I figured, like I said, I mean, it would have been fun to build and do all that stuff, and I think it would have been pretty helpful. But I figured, naively or not, that I had, the next 10, 20, whatever years of my profession to catch up in that side, but only really one shot to go to school full time. And
Okay.
so I just thought that I should try to maximize that.
And your grades were good?
Yeah, they were pretty good. I mean, I was probably like a B plus student. I mean,
Oh,
taking too
perfect.
many classes was made it hard to get A's. And
Yeah.
but you kept, well, hopefully, but you tried obviously not to get any C's or anything too low. So I did good given there were hard classes and that I was cramming more than I probably should have in any sane world to do in a week.
What happened after the university?
After university, we had a big recession, so that kind of sucked
Oh,
to graduate
2008, I
into.
guess, right?
Oh no, it would have been 2004, 2000, something like that. A couple years earlier than that. We had a tech recession after the dot-com bust, and it took a long time for
Okay.
that to kind of
But
recover
this
for
was
new
more
grads.
in Germany was like, it started 2000, 2001.
Yeah, we had something like that with the dot com bust, and then it took a couple years because I mean you would have you'd only want to hire naturally experienced engineers. If you're
Okay.
coming out of school as a new grad,
Yeah.
even if the industry is starting to recover, it's still harder. So that was when I came out of school, and then but but yeah, I mean then we then just more towards programming because that just fit me better, and also was just what the industry was needing.
So you started a company or you started to work as a freelancer consultant or what you did after your university?
Oh, I went to a company that did travel. So basically, they did like a travel platform, kind of like but for corporate travel.
Okay.
So the company changed names a couple times. They
Okay.
they were, but basically, so if you're doing, they'd have to talk down to the old mainframes, the GDS systems,
Okay.
and so you do air, hotel, car, and you'd be booking them, but they'd be doing it for corporate travel. So you'd have
Okay.
a bunch of expense management rules to say, yes, you are as an engineer, you're only allowed to book normal economy, but if you're in sales, you get business class, and these are our preferred airlines, and do all that's expense management. And so basically working on their platform for a couple of years, and then went
In
off.
which programming language you choose? C, C++ or?
They did everything in Java, so
Oh,
that's where I
Java.
got
So
that.
this was your introduction to Java.
I'd done some Java in school, but that was
Hmm.
my first like real world introduction in Java. So we were started off on Java 4 is when I
Okay.
when I started the company. I mean, it'd been around for
Yeah.
a couple years, and then we went to Java 5 and maybe 6, and then I jumped over to Google for a couple years and on and
Oh,
just always kept with Java.
interesting. So and you liked the Java experience?
Yeah, I think Java is great. I know that you always have haters online, but whenever you touch anything else, it always feels like you lost something. You know, the JVM in terms of inspecting and profiling, in terms of like the tooling for language, like IDs and everything else, it's just very flexible, great documentation. You actually get to go look at the source code. So I'm sure you remember back in the day that if you wanted to, try to figure out how a library worked, most of the time you had to go look at some very arcane documentation. You didn't get the
Mhm.
source code, so being able to just jump into the code and kind of skip over docs was always great.
Yeah.
So I always thought the Java was great. I know people have their own opinions, but Java and the ecosystem around it has always been really nice.
Yeah, and I'm even worse, Yes, I do Java since JDK 1.0, and I
Mm,
still really enjoy it. So it is
yeah.
never gets boring. So for me, it is just greatest time ever, and this doesn't look like I just losing the interest. This is yeah, it's a great language. And why you switched the companies from the travel to Google? I mean, it is almost obvious, right? Google, but was it your plan to go to Google, or was it like a lucky accident?
Well, the company was in a the company had struggled with that recession in 2008, like you
Okay.
were talking about,
Oh, 2008
and
now. Yeah, great.
yeah, so by that time, so I'd been there for like 40 so years, and they were struggling, and I'd been there for a while, and then so it just was time
Okay.
for myself, and bunch of people were also leaving, um, and so it just wasn't as healthy of an environment,
hmm
and then we're just interviewing, and I had a colleague, a former colleague at that company who had gone off to Google a
hmm
year or two before, and so then I just kind of followed his path and joined his team.
hmm
But that was,
how was the interview at Google?
that was like a 6 hour interview, I think.
Yeah, yeah.
You basically, it was like 10 o'clock till like five or something crazy because you had a lunch in between. So I met with that guy for lunch, and it was just nonstop of 1 plus hour interviews. But it was fun. I think I was able to do pretty well throughout it, except for the last interview when I was just tired. And I got an answer, but the interviewer was trying to push me to give the more optimal answer. Like, I got the right answer, but I mean, it was like you could get a little bit further to really crack it and do something really neat. And like he knew I could get it. Like I was almost there, and I would just waste it. I was just tired. I was like, I'm tired. Like, I'm interested, but I just can't think anymore. And and I mean, it still was fine. It was just that was the only disappointment for
What
me was
was
that
it roughly? You remember what it was? Which task was it?
it was something to do with the binary search tree, and
Okay.
I don't remember the question off the top of my head. That's been too long, but it was some trick around binary search trees, and I had the core part of it. I had the answer. I had the core part of it, but there was some special trick that would just make it really elegant, and I just couldn't make that leap
Okay.
at the time. And I think he was generous because he didn't really seem to hold it over me. He just pushed me for like 15 minutes on it, and then realized finally that I was being honest when I said I was just done.
Okay.
It takes a lot out of you with those with the Google style interviews for a whole day. That took a lot takes a lot out of you.
And you started Google. What you did at Google with Java?
So I basically decided to follow my friend, my former colleague. So I just thought, and having not worked at a big company, I only worked at a startup before that. I didn't, want to I didn't really want to do, I figured play it safe, learn from people I knew, and then gradually move around. Um, but they were working on effectively their version of Salesforce.
Okay.
So kind of how they everything internal for their own CRM and sales would all go through a Google CRM, and so that was a team that was building their Salesforce, which they always talked about eventually competing, and they never did. But it was really an in-house sales stuff. And so what I worked on was their one approach towards integration was if you remember iGoogle a
hmm
long time ago,
hmm
and that was a way of punching out these little gadgets that could punch out to other systems.
hmm
And if you got a big company like Google, they got a lot of these disparate systems from like DoubleClick and others, and some of those are on Salesforce, some of those on Dynamics and on other other custom built systems. So their approach was, well, sometimes if we we'll want to feed in all the data and get it all, but other times we just need to give the back office people an ability to punch out and just see information in other systems, and then even have some control within this one system to make edits that would then get reflected back.
Okay.
And so they had taken iGoogle, which was C++, and they had forked it to make their own gadget container that would have a lot more features. And iGoogle was dead, and they were basically the ones keeping iGoogle alive because entire sales system at Google was dependent upon it. And so when I joined, they needed a project to rewrite it from scratch, effectively with more features for role-based and other type of characteristics, more enterprise. So that was called patchwork. And so I did design and then implementation with another engineer who'd been there for a while to build out basically our own version of iGoogle, but with a lot more enterprise features for and then that was kind of the way for dashboards and for other customizations for their CRM that would then integrate with all the other systems. So that way, you could still integrate without having to bring all the data, because obviously bringing in all the data, those deep level backend integrations, is a lot more work. Whereas if you can end up saying, if this is all you need, let's do a front end level with a gadget, and then have that punch out. And then if there's more, we can promote that towards a real integration.
And you did it with
that
Java.
was a strategy. Yeah, that was all Java. It was using it was actually in Gwt. So that was Java combined with JavaScript. And so that was I'm always a backend engineer, and so that was my first kind of real foray, other than doing a bits and pieces of struts on the front end. But that was still Java, and then got to design it using a lot of the backend kind of engineering patterns. Since it still felt like a real backend kind of system.
Mm-hmm. And was Java without any frameworks, or just plain vanilla Java, right?
Well, Gwt is kind of a framework by itself, but it you would use on the back end, obviously Google used Juice for its DI.
Yeah.
And on Gwt, you would have Gin, so Gin and Juice. So Gin is the Gwt injector. So that would be, basically just Gwt and Gin were your frameworks, and it didn't really have much structure to. It kind of feels like plain JavaScript in that sense. Like those are the basics. And so you'd have to build more of a structure, because there wasn't a real good way of how you build up your component hierarchy and the rest. And so, but yeah, it would just be, it was mostly just Gwt and Gin on the front end, and Juice on the back end, and no real other major frameworks, bits and pieces of what Google had their own version of Jetty kind of systems and other stuff like that. But again, it was just like a bare bones kind of Java system.
I'm not aware of Gin. What is Gin?
So Gin. So if you're aware of Juice, so Juice, of course, is server side, and Gwt was Java compiled to JavaScript.
Yeah, of course, that's what I know.
So Gin was a dependency injector that was for client side.
Okay.
So and that's why I was saying Gin and Juice, the old rap song. If you're aware of that, that's why I think this line came from. So Juice on the server side, and then from Juice they needed dependency injection for client side, so that became Gin.
But Gin is not open source. This was internal Google project, I guess, right?
I don't know. I didn't follow Gwt after I left. I knew Gwt was pretty much dying, and it seems like it never really took much speed. So I assume it's probably an only internal Google project. I don't, but I mean, maybe they open sourced it. I honestly never followed.
And what SCM?
Wasn't
source code management tools you used at Google. So was it like a monorepo, or was it a subversion, or what was the story with that? So
Google uses a monorepo.
Mm-hmm.
And at the time they used perforce, so a very massive perforce system. Those were at the time the largest, most powerful computers.
Mm-hmm.
And then when I was leaving, they were working on a replacement. I think it was called Piper, and that's what they're using now. And that basically is a perforce rewritten by Google to be Google scale. So it would be based on Bigtable and all the other core technology at the time. But it would basically speak the perforce dialect, and then I think they had a Git wrapper for people who were into Git, and Git was still pretty new at the time, but you could use the kind of Git commands that would get translated across. And
which build system have you used? Ant or Maven or something?
Well, at Google, of course, they use Blaze. Now that's called Bezel.
Bezel, okay.
But that's what they use. It's called Blaze, and I like the original name better. And that was, I think that's the best build system I've ever used.
Why?
It's just very powerful and elegant. It's just you construct everything as rules, so you don't have one big build file which just grows as this monstrosity as you get more and more code. And I really like the structure that you could do in Ant and Blaze, which is you make more of a source tree. I don't particularly like how the Maven module style, because now you have lots of these little modules which
Yeah.
sometimes don't really mean very much. Sometimes we'll do functional, so it'll be model view controller modules. Sometimes they'll do it by components. They're all flat at the top because most people don't build out the hierarchy. And then you have the nesting again. It doesn't feel like it scales as well. And when you have lots and lots of modules, and Gradle took the same model there, and Blaze or Bezel took it as just one big source tree. And every package had its own little build file. And that build file is only like 2 or 3 lines. It just says, these are my dependencies, and you could add more, glob and other things. You could add more complexity, but most of the time it was pretty straightforward. And then you could just stitch it together by it would build up its own dependency graph and compile and cache that stuff. So you didn't run into these issues of this module. Well, what layer of my system should it be in? Because I want some utilities and I want to reference it somewhere else. But now now I feel like I'm having to go towards old C++ style layering and how all these things are interconnected rather than Java natural style of my package. My package is this. I can scope my package, and I can say everything under this subtree is private because this is the whole application. So I don't want some other application to be peeking at my internals. So it just felt more powerful, more more kind of like, I'm sure now with Jigsaw, more like that module style as well. But definitely just felt more elegant, more natural to work in. But took a little bit more effort to maintain because you have to add more.
And you could release the software at any time. So this was like, so you could just push the buttons released, or how it is worked?
At their world, basically you always committed. So everything was, once it was committed, it was buildable and would get released for anyone who might be doing a release. So if you say contributed to Guava, then within a commit or two, it might go out with on the ads team or someone else, because everything just got merged in and you just put more time into and your effort into testing. And then, but I think every team would have its own release cycle. So I think my team probably had a release cycle maybe once every week or two.
Okay.
I don't remember too much about that, but basically once it went into the mono repo, it was therefore, it could get picked up by anyone if it was a shared library. So you could start hearing back feedback, error, bug reports, and everything else from a team, that's in other side of the world that just is releasing, and they picked up your bug, and now you gotta go kind of fix it.
Cool. What happened after Google? So you left Google?
Yeah, I went off to a company that was only that was like a couple blocks away from Google that was doing financial analytics, and so I was kind of leading their platform team to basically they would do a lot of portfolio management, a lot of like bring a lot of data manipulation, stuff like that to and so so I just jumped over there, and then from there I went off my current role, which is more in the logistics space.
Okay. So now you're working still with Java in logistics space, right?
Yeah. So now, we're basically doing more trucking logistics. So, for example, right now we've been pushing a lot with COVID on contactless pickup and delivery. So mobile and backend and kind of custom workflows for to allow truckloads. So this would be, for example, we are rolling out this week to all of FedEx's like 600 facilities in the U.S. And so they have at their facilities, they'll do their sort and packaging and everything else, and then the trucks will have to go between facilities, of course, right? Because you have to move it across country. So those are all full truckloads of a lot of parcel, and so they'll be using our stuff for the driver check-in, for giving them a door number to unload at, all that kind of stuff to keep everyone spaced out, and then of course also for there's other workflows of course that FedEx has, but in other companies as well. So it's not, we don't do as much. We do some on the last mile. It depends on the company. So parts where they get the proof delivery and sign, and they'll do a lot of that stuff in our mobile app, and then the back office will use our Java web app to deal with invoicing and to deal with other aspects of their business there. But yeah, it's pretty much it's still very much of a Java shop.
Yeah, interesting. So now obviously it's more than Java 6 or 5, whatever you did back then. So you're a recent Java 11, I guess, right?
Yeah, we're on Java 15.
Well,
I mean, we're not paying for an LTS, so I kind of if we're not paying, then the recommendation is to stay on the latest.
Yeah.
So I think we're either on 14 or 15, and if we haven't gone to the latest one, it's just because I haven't bothered to go through that extra step.
Yeah.
But yeah, I try to keep us on. I think the Java 8 to 9 and 10 was a little bit painful.
Yeah.
You had to kind of deal with some of those
stuff, right?
issues. Yeah, but after that, it's pretty smooth, and so it just seems better to upgrade after you get a little bit of time for Eclipse and others to kind of get their upgrades out live.
Before your company right now, can you reveal the name of the other company? So a few blocks away from Google, what was it?
That company is called Adapart.
Okay.
And so they're still around. They're doing a lot of stuff with like JP Morgan and others.
Oh, okay. And why you left Google and walked a few? I mean, Google is a nice name, right? So you were bored with Bezel.
There's a lot of big companies have a lot of the good things and bad things, and there'll be subcultures. So in that subculture, at that area, it wasn't the healthiest.
Okay.
And so I did not enjoy my experience there.
Okay.
I enjoyed my experience with when I'd work with other teams, like on 20% side. So when I'd work with the Guava guys on the caching and stuff like that, that was always really fun. But my direct team, I did a lot of good work there. I got a nice promotion and stuff, but it just wasn't very healthy.
Okay.
And it just wasn't a great fit. And so I found myself I started at startups, and so I went back to startups because it's just a better fit.
Yeah, funny. Because for me, Google still sounds like startup. For me, if I think about Google, I think about startups, but it's a huge company actually right now. It's an enterprise company, but I still have in mind, Google's small, nimble startup. But it's actually no more true.
Yeah, I think the problem is that the further away you get from the customer, the more it's hard to tell whether something is whether what's being built is the impact of that, and so you start getting more and more oriented people, about performance review. So every 3 months you had to do a performance review, and every 6 months it was a larger, more feedback one. And so everything was about the performance review. So even if you did well, you still had people were stack ranked. So so on your team, your competitors. That one teammate tell me that, but at a startup, you weren't thinking about your teammates as competitors. You're thinking of it as your competitor's your competitor. So you're focused on coming together to go solve a problem, not being afraid of being stabbed in the back because a teammate is afraid and wants his performance review to be better than yours.
Yeah.
And unfortunately, that subculture had that characteristic, and so I didn't enjoy that. And they played some games to keep me from switching. So they had at big companies there's things like Google is named from like code red, yellow, and purple. They say like code red is like Gmail is down, code yellow is like Gmail will be down like in a couple months if you don't scramble, and purple and stuff. And so when I was trying to get out, they switched they pulled me back with a code yellow on their team, and it was just a lot of stuff I don't want to I'm getting into too much already, but it just wasn't a great fit. But like I said, that's a subculture. Different teams, I'm sure a lot of people really enjoy their experience at Google, and I just wasn't fortunate to have found a good fit.
I think it's not the Google. It's every large company. It is there are some politics in place, and I was always a freelancer. I've just observed it from outside, and I would say all big companies have some problems with politics, or they forgot why they are building the stuff or whatever. There's lots of stuff going on where no one understands, and for us developers it's not logical what's going on, right? There are lots of funny stories. So now I was just curious whether you found okay, and the other company you worked with was the was it Java what you did still?
Yeah, the first one I worked at the time, they were called Reardon Commerce, so named after that old Ayn Rand book. I don't remember the name of it. And they were doing travel expense and management. I think they renamed themselves to Deem, but I don't really follow them too much.
Okay.
Then it was at Google. Then it was at the company Adapar doing finance. And then
it's still with Java, right? Other part you did also Java.
Yeah, my entire career has been Java.
Okay, nice.
And then the current one is Vector, where we're doing the logistics side of things.
Okay. And which software are you using now at Vector? You said, right? Vector.
Yeah. So I mean, it's still a startup. So
Nice.
when I was building their stack, I didn't, you kind of want to use somewhat boring, tried and true, don't go too crazy. It's it's Jetty with JaxRS, with Juke, Juice, um,
Crazy.
and then
Nice. I mean, really
yeah,
lightweight. So I mean, this is
yeah, very
yeah,
simple.
yeah, very simple but unusual. This is what I wanted to say. So Jaxores, Juice, perfect.
Yeah,
Jetty, okay, and Juke is this query language, JOOK, right?
Q, but yeah, JOOQ,
JOOQ,
and
yeah,
yeah,
Juke.
yeah.
Yeah,
So that's, and then and then that talks to Postgres. We have Elasticsearch, and we have some of our own kind of our own framework type
this
things.
is
They're very
actually
lightweight.
a newer startup in Bay Area.
Yeah, yep, in the Bay Area. And so
Yeah, well,
yeah,
I would actually I would judge, and I would say your stack is boring in a good way because it
yeah,
comprises proven technologies, no funky stuff,
exactly.
and it just works. And yeah, and JaxRS, what they're using, Jersey?
No, I got burned with Jersey 2, or I think it was when Jersey 2, when they tried to do their own DI and it wasn't compatible with anything.
Yeah, context.
HK, I think it's called. And it wasn't, and to get it to work with Juice at the time was like really painful because they do these weird statics. And I think it was even painful with Spring, which I haven't used since Spring 1, I think. So my Spring knowledge is pretty out of date.
Hmm.
But so getting burned, and also the Jersey team at the time, I don't think they were very well funded because it was, Sun was dying and Oracle's taking it over, so they weren't very responsive to the community. So I switched over to Rest Easy.
Okay.
And Rest Easy has been great. I mean, Rest Easy, it's very pluggable. The team's been wonderful. The only issue I ever had with it, honestly, was I found a hash DOS exploit once, and they were very quick to fix it. But everything else has been wonderful. So it's just JaxRS in the end of the day.
Yeah.
So it's very very smooth and very easy.
Interesting, because I usually prefer Jersey over Rest Easy, and the reason being is because with Jersey it is easier to create system tests. Because if you would start Rest Easy in a unit test, there were some problems with connection closing. They just they in one point of time they were stuck. You will have to create to configure your own HTTP connection pool and to do it properly. And Jersey worked out of the box, so I always preferred Jersey. And I always used more than you, so I use Whitefly or whatever. And then the dependency injection, Payara, Whitefly was already solved for me, but a very similar stack. So if you look properly on my code, almost the same code, because Juice results in at inject with Jersey, so there will be no difference, I think, in the source
Exactly.
code.
The Juice and Spring guys came up with that JSR for inject.
Yeah, exactly. Which is crazy, because what I noticed recently, that Spring doesn't use the at inject from Ron Johnson anymore. So like they
still use AutoWire, which is crazy.
Yeah, they forgot their own standard, which really
I know.
struck, because I don't know whether you follow the history. Is one point of time this Java 6 was almost done, and then Ron Johnson came out with the Juice dependency injection, and they afterwards
No, it wasn't Rod Johnson.
Ron Johnson and
was
Crazy Bob Lee both.
Yeah, Bob Lee did Juice with a bunch of other people at Google, and then but then he and Rod Johnson did the JSR.
Exactly.
To do the added
Exactly.
Yeah.
And then in 6 week, they pushed the spec, and which made the Java 6 late, because they just took the CDI dependency, not CDI, the Juice dependency injection, this at inject, and they refactor actually Java 6. And now the crazy story is, now because it came out of Spring, more or less, Rod Johnson, but Spring doesn't use it anymore, and we still use it, right? You use it, and I use it, and Spring doesn't use it, which is crazy.
And I don't know why Spring still prefers AutoWire. It's just probably historical. But I'm also, Spring was always a little bit weird. Like Juice had the nice observation where a long time ago Spring pushed everything in property-based injection, which made sense given the XML world. But of course that meant that your objects weren't always fully materialized. They were, they weren't in inconsistent state when you construct them. So Juice, being very type oriented, did constructor injection, and then Spring eventually followed suit. And nowadays, I think, but I still see, whenever I see people write sample code online and I kind of see what examples people make, they still just use property, but they just use private properties. They don't even make it as public setters or anything else. They just auto wire private fields, and you kind of therefore break some of the initial ideas that Rod Johnson and others had, which is that you're wiring up your dependencies, and the injector is kind of just behind the scenes. You don't need the injector to write tests. You don't need that type of stuff. But and I might be totally wrong, because like I said, I haven't used Spring since 1.x days. But it looks like, whenever I look at people's sample code on GitHub, it looks like they're very much tied to Spring, more so than what Rod Johnson at the time would have been promoting back in his early days.
I never had the opportunity to do a lot of Spring or anything with Spring, because I'm spend lots of my time with Jakarta and microprofile, actually all my time. So never had the opportunity. But what made me, how I found you is because of Caffeine. You've wrote a nice cache.
Well, I was actually starting that stuff back, I think, when I first started playing with that stuff was back in 2008. Mm-hmm. So I was doing performance work at my first job, and at the time, caches were just synchronized linked HashMap in LRU mode, and so we were running into performance issues. So I was I was introducing Memcached, which was still pretty hot in those days, as a remote cache with a local in-memory cache.
One questions about Memcached, because you are the cache expert. So for me, from Java perspectives, if it never made sense in projects, and it caused a lot of trouble. So as Memcached came out, lots of Java projects in my enterprise project wanted to use Memcached. But what you had to do, of course, you get to serialize the Java objects and move them to Memcached and pull them back, which was sometimes more expensive than keeping them, in the local HashMap, or just getting them from the mem.
That's why at the time when I built out their caching structure, when I was initially for performance and scaling their system, they were already using local caches, and those, like I said, they were just basically LRUs. And we made Memcached as a remote layer, so it's second level cache.
Okay.
And then in that way, you didn't hit the serialization penalty as much. And then we were using JMS as a that's what all of our RPCs and everything else is on. So that would send a broadcast to do a cache invalidation as needed. And then we would do a bunch of pre-warming as well, just to try to pre-warm Memcached or pre-warm the local caches to avoid a lot of unnecessary hits.
So you use never Memcache directly. You use Memcached more or less like a almost database second level cache, which was the second. Yeah, it was like the persistence almost of your cache, right?
Exactly. So so you still used it, but we didn't use an application code. It was,
and you mean Caffeine project, the Caffeine project from the beginning, right?
So at that time I was working. So when I was working on that, I also had to do other stuff with, like, our front end was all kind of JSP kind of template type stuff. So we use a lot of EL expressions, and so that was hitting for every UI render thread, it would hit these locks on the server trying to hit the cache. So I was trying to fix those performance bottlenecks. So at the time, you didn't really have good concurrent caches. So I was interested in concurrency because Java 5 was still pretty fresh, and so I was trying to figure out how you build a concurrent linked hash map. So linked hash map is a data structure in Java which can be set to become an LRU and then evicted. And I wanted to figure out how would you do the same thing in a concurrent fashion, and that turned out to be a very hard problem, which is why Java never built one. And then I eventually figured out that that's open source. That's a library called Concurrent HashMap that got used by a bunch of people back in the day, like Cassandra and others. That's when I was figuring out the algorithms there. I went over to Google. At Google, I worked with Kevin and others to build Guava's cache. And so I was kind of taking the bits of algorithms that I figured out from the current linked hash map, they had already built MapMaker and some other type of stuff, which was a predecessor to Guava's cache that didn't really have the greatest algorithms, but it had its own ideas that were sometimes good, and it forked concurrent hash map. And so trying to figure out how I could bring my ideas into their existing data structures, which kind of corrupted my algorithms, because we just had different opinions of how things should work. But so we built out that. So I had more of a consumer-oriented kind of trying to get something so that Google had a good caching library and not a lot of these bespoke ones. And then after a couple of years, Java 8 came out. I didn't feel like I'd be stepping on toes to rewrite Guava's cache the way I always had said it should be, but I was a nuclear. So
Yeah.
they weren't going to listen to a nuclear. They were going to listen to the other guys. So so I figured I wouldn't be stepping on toes. Java 8 was fresh. Everyone who'd worked on it basically no longer worked on Guava's cache. So I figured so something like 2014, 2015, when it was just the holidays, it was just Christmas break, and I figured this would be fun. Java 8 is new. I want to learn Java 8, so let me go write cache. So
Okay.
I started as I just started writing Caffeine, and that was and then it worked.
And back then, cache was not good enough. So you are you aware of cache?
I'd use cache my first job. That's what we'd use as caching at the
Okay.
time. But cache was still at the time it was cache 1, which was still a big synchronized LRU. That's all it was.
Okay. So this is what I didn't know back
with,
then.
with its own disk cache and other really great fancy things. It was well designed, but again, there was no real concurrency
Okay.
because the concurrency was the assumption that it had only concurrency to say that it would when you have a self-populating cache that would take a different lock, so that when you were loading an entry, you didn't have your cache stampede where another thread coming for that same key would also load at the same time, and therefore you're doing wasted work. But you don't want that loading to then block any other cache hit because it's taking out some global lock. So cache had a self-populating cache, but when you were using it in a in memory, like the UI level, where it was server-side pages that were constantly getting hit to do these EL expressions from in some EL cache, that HashMap level lock was still too much. And so that's why I was trying to figure out how would you write a proper concurrent data structure.
Okay.
And that's when I wrote my concurrent linked HashMap, and then from there, just kept going. I didn't use cache beyond that. I know that they made improvements, but I didn't. It was no longer needed on my work.
The Java 8 concurrent hash map. So my understanding is how it works is if you access the concurrent hash map from multiple threads, it works like each thread gets a small region, like almost like a sharding inside the concurrent hash map. Is it correct point of view how this works?
So the Java 5 version is basically many small hash tables based on the concurrency level.
Yeah.
And so then it's a fixed set of hash tables, and reads of course are lock free, and writes take out a segment lock, and then they're exclusive. And that works pretty well. It just doesn't scale to a very high number of cores. So you start running
because the region becomes too small, right? So if you have a number of cores, the region becomes smaller and smaller, and this is why it doesn't scale.
Yeah, the fact is that your entries will more likely challenges like if you have lots of writes, your entries will likely hit some of the same segments.
Oh, of course. The amount of segments was fixed, right?
Exactly.
Okay, this is what I'm misunderstanding. I thought the amount of segments is the same as the amount of CPU. No.
Basically, you'd set it by concurrency level. So the default I think was like 8 or 64 or something.
Okay.
And so that was the old Java 5 one, which was very well designed. It just for high writes, it just didn't scale as much because it wouldn't scale at usage. It would scale at construction. And at construction, it would be large segments no matter what. So you'd still have a good chance of collisions. And in Java 8,
excuse me. So I was actually wrong. So the segments were not too small; they were too big. Because if you have 64 segments and you have a huge hash map, so there are lots of entries per segment, and if you have lots of CPUs, the chances are very high that you get contention inside a segment, right? This is the problem.
Exactly. And so in Java 8, it's been rewritten from scratch to use such that you have instead of segments, they call them hash bins, but kind of the same idea. But effectively, it tries to have very many small hash bins. So you'll have a table might have hundreds of these little hash bins, and each hash bin is of course the linked list chain for the closed addressing. And so this way, and it scales with the capacity. So if you have a very large concurrent hash map, you'll have more bins and therefore more potential write concurrency. And it was important for them to do this because Java 8 also introduced the computation methods. So compute if absent, compute, merge, so forth. And so they lock on the hash bin. So and you want multiple computes to be able to happen in parallel, and you fix the number of locks up front, then of course if you only have like eight bins, it's going to be problematic. In Java, that's where that's where Guava forked Java 5's HashMap for Cache Builder in order to allow it to do more of that self-population of a loading cache without taking out the segment level lock. But you're now dealing at the low levels of a hash table, and so it had a lot of complexity because of that. And Java 8, of course, it's built-in feature and is designed for scale, and it also handles hash DOS attacks.
Okay.
So if you have lots of hash collisions, you want to degrade to, in their example, they degrade to a red-black tree. So it handles more things, much more versatile. And so yeah, that's how Java 8.1 works.
Okay, and how is your implementation even better than Java 8.1, right? Because you created something even better than the Java 8 version.
Oh, so I built on top of Java 8. So in my original kernel HashMap, I decorated the underlying hash table.
Okay.
In Guava, they had already forked it in order to add their own ability to do loading to load entries and not take out the segment level lock during the load, and other features like soft references, and that added a huge amount of complexity and limitations. And so in Caffeine, I went right back to, again, the way I preferred, which was decoration, because I knew that the hash tables would evolve as they had in Java 5 to Java 8, and I didn't want to. I just didn't see there being a need. There's enough complexity of the cache to not also embedded with the actual hash table side.
So what you are doing with the Caffeine, you are wrapping the concurrent hash map and you're adding cache-specific features around concurrent hash map, but you are not more concurrent than the current implementation of Java 8. You are just as concurrent as Java 8, but you are adding cache-specific features on top of concurrent hash map, right?
Exactly, and and you can never be faster than your baseline. So in that sense, like, the caching will be more expensive because what makes caching interesting and hard from a concurrency perspective is an LRU is the least recently used item. So that means that every single time you access the item, you're updating its state to say, oh, this is now the least recently used one. So that if you want to traditionally, like a linked hash map, that's maintained on a doubly linked list. You look up the key, you find an entry, that entry embeds the previous and next pointers. You can just unlink it and then push it to the tail and link it back as the least recently used. And the problem is that with concurrency, well, every read is a write. Every single time you're reading the entry, you're modifying internal shared state. And well, that internal shared state is not only just the two pointers, it's also the tail where everything is being moved to, so you're having contention there. So that was a hard challenge of trying to figure out how would you make a current LRU that maintains that property when every read is a write. And so,
that means that reading from your cache means it doesn't have to be strict, because some read writes can get lost. I don't care. The last has to win, right? So if I'm reading, and I'm reading I'm reading first time, and at the same time I'm reading the second time. So the first read can get lost because no one cares. I only have to know that I read, right?
Yep, exactly. So the cache policy can be lossy, but from the data consistency has to be strict. So the user should always, so the hash table is always the latest version, and you always should get the consistent data. But the policy of what it means, it has to have the data structures have to be correct. They can't be corrupted, but they don't have to be strictly every little detail, because you're gonna have concurrency, which means non-terminism, as you're saying. So you can be somewhat lossy if you have too many reads. You would prefer having better throughput than it would be about having it strictly if every little read is taken into account. And so the trick that I used in my caches has been to use ring buffers. So you basically instead of basically applying the work immediately, you publish the work to a ring buffer, and that's cheap. There's no allocation, and then when the buffer gets full, what's a subscription is a policy, so it gets replayed, and you just take out a try lock to say, okay, when the buffer is full, take out a try lock. If I acquired the lock, wonderful, I can then replay all the work that's been buffered, and if not, I don't care. Someone else is doing the work, and so you can take that as style of publishing and then replaying. And then if the buffer is full for a read, you don't care. It's like, well, I can't handle that throughput. And like you said, the maintaining strict LRU isn't the most important thing. I'd rather hand back the value as quick as possible. So you just drop that read.
You could even have one buffer per item, right? It would take more
I
memory.
do it basically per thread. So I
Okay, perfect.
basically
Okay.
I do dynamically. I use in Java 8 also introduced dynamic concurrent counters like
Okay.
long adder.
Yeah.
And so behind the scenes that uses a data structure called stripe 64. And so it's the dynamically growing data structure. As more concurrency happen, add more contention, it'll add more cells.
Mm-hmm.
And therefore we'll just stripe it across the number of CPUs. And so I take Doug's work and I adapt it over to these ring buffers to dynamically grow. So it starts off with 0. You haven't allocated, you just created the cache. We don't allocate upfront.
Mm-hmm.
And then as you're adding more and more threads, it will dynamically take up, expand how much it needs to be able to meet your requirements.
Mm-hmm. Crazy what you're doing, actually, in your leisure, right? Almost.
Yeah, that was basically, at first it was just, fun to do after work on the old projects. Then it was, like I said, I started off just in over the holiday break. And then my current job back before the pandemic, I had about an hour plus commute on train. So that's when I'd work on it. I'd just be on the train and just work on it. And I was just, it was nice to do a real like computer science style projects while you're off at work doing meetings and other type of things that are a little bit less fun. So that was kind of my distraction.
Meetings are less fun, so we are very similar, I would say.
Yeah.
And
so I'm stuck in meetings all day, so that's kind of my escape.
Okay. And which features Caffeine comes with? So, I mean, if I will use Caffeine, is it like a Maven dependency, or what is it exactly? So, how I can use it?
So the idea with all the caches I built and Guava as well was always trying to be an extension to the Java collection framework. Mm-hmm. So don't reinvent the world. Don't make up new versions of futures or other concepts. Basically, take the Java collection, which is really well done, and just extend it to do what would take Josh Blosh, who reviewed our API for Guava's cache. Well, how would he maybe design a cache if he was going to go build one, and try and feel natural in that ecosystem. So in that sense, unlike things like EHCache and others, which feel like framework, you have XML, you have managers, you have that type of stuff. All of the ones I built feel just like any HashMap. You knew it up, you do it, you configure it however you want to configure it. Like I don't care if you're using YAML, JSON, INI, whatever you config. That's your choice. It's just a data structure. It's just like bringing in another random data structure you might like that could be a radix tree or whatever it is. It's a data structure. Okay. So it's just a Maven dependency. You bring it in. You use the Guava style builder API, and then you decide. It's like any other hash map. So you decide that lifecycle, its configuration, how it gets used, and we just try to expose caching more cache-specific API that kind of leans you in the right direction, and then has an as map, basically escape hatch and say, oh, you know what? There's things about a map that I want to do. Maybe I want to iterate all the keys, do things that make sense that aren't what you normally should do. Ideally, you aren't looking at all the entries in a cache because it's supposed to be, data can come and go at any time. But if you want the map view, sure, you can use it as a map, and do other exploration features or whatever. So we have those hooks. But in the end, it's just a fancy concurrent hash map. So it has it has its eviction policy. So I was more interested in the concurrency side, but after I kind of had that figured out, I started exploring the eviction side. So working with some guys, some researchers in Israel, they'd come up with a really elegant scheme called Tiny LFU. Okay. And so then working on their scheme and using more data sets and kind of understanding it better, was able to advance it further. So we came up with improvements towards that to make it adaptive. So some workloads are frequency, some workloads are recency bias, some workloads are a mixer, and we'd adaptively tune based on the workload. Other tricks like that.
This is crazy what you're doing. There's some usability stuff as well. So you have almost ergonomics, like the garbage collectors or your cache.
Yeah, and it's dynamic. It's behind the scenes. You throw a workload at it, and we'll figure out how to optimize.
That is crazy. So which policies do you support? So you have last recently used. What else?
It's internal, so you don't actually. We keep the users ideally shouldn't have to go tune those type of things. You shouldn't have to say, I want LRU or LFU. You should say what features you want. you want expiration on this type of, after write or on create or something. You want
Okay.
a maximum size. You describe kind of like SQL. In SQL,
Okay.
you don't say this is going to be a B tree and this is how you want to do it
Okay.
or something like that.
What you can describe?
So you describe things like maximum size. You describe you have a cache loader to say, on a cache on a when a miss occurs, here's how you load the entry.
Okay.
Here's if you can describe the refresh policies. It says if an entry has been is accessed after this duration, I want you to instantly reload it.
Mm-hmm.
Have support for all the completable future goodness. So you have asynchronous cache, so things aren't blocking. Removal listener. I'm not a huge fan. I'm not a huge fan of soft and weak references, but that's part of Guava because the original author of Bob Lee, he was a huge fan of soft references. He thought that was an answer to everything. Turned out to be wrong, but I can understand why he thought that way at the time. So I supported it. It didn't make everything designed around it, which is what kind of limits Guava's performance. So lots of pretty much every feature you might need, or at least flexibility to let people build on top. And then the internals do things like we use account min sketch to maintain a frequency histogram, a timer wheel to support variable expiration. So both of those are O1 data structures. So you don't have to maintain log n priority queues, which will degrade your performance. We use hill climbing to dynamically monitor the hit rates and then try to tune based upon try to tune our internals, trying to figure out how to maximize your hit rate. Mm-hmm. It's just a lot of data structure algorithm fun on the inside and just the core usability APIs on the outside.
Okay, so what soft reference means is that it is going to be garbage collected basically. If the JVM is running out of memory, they can be collected, right?
Yeah, and it's collected in a globally LRU fashion. And the problem with it is that you're effectively putting a lot of weight, a lot of penalty cost on the garbage collector because it'll mostly only do it traditionally during a full GC, not during and so what happens is that it says, okay, well, you keep it around until I'm out of memory, which means that your entire heap. So let's say you only have 1 gigabyte of live objects and you have maybe a 2 gig heap or whatever. It will fill up all the remaining space with these dead objects that are available that could be resurrected. And then that means that you're constantly hitting a point of needing a full GC. Because if the garbage collector only collects stop references traditionally at a full GC, that means you're doing a stop the world. So you're basically forcing the garbage collector to do that, and the garbage collector stop the world, stops everything. That's the whole point, and then it does its work. So you're forcing it to go into this GC thrashing mode of, I fill up the heap with all of this extra cache data, then I stop the world, I clean it, not really understanding which things other than global LRU. I don't know how valuable things are, and then I clean, and then garbage collector will only clean up the amount it needed to unstop, and then very quickly again you stop the world again because you filled up with just activity. So you'd be hitting this GC thrashing and your performance would degrade because you put the penalty on the GC.
But as a last option, this could be interesting, right? Not like as a strategy, but I say, okay, I have my options, but if it fills up, then I could use soft references. But what I understood is there's still lots of overhead involved, right? So the penalty is rather high.
You're basically you're making the overhead soft references look attractive because from a programming model, since you aren't maintaining any locks or any other concurrency, it's a JVM. It looks like it's very cheap because you can write a little micro benchmark and you can pound it with threads, and it's exactly the same cost as unbounded current hash map. And behind the scenes, it just removes the entries when they're expired, and you're done. The problem is that while you're on the application side, it feels very fast, and that micro benchmark in the system performance has dropped to be abysmal because you basically pushed all of the cost on the garbage collector, and you're telling the garbage collector to go into stop the worlds continuously because it wouldn't collect everything. Because you said, hey, any extra free memory, leave that open for my soft references. So it only collect enough to continue working, and then it would immediately run out, exhaust its memory again, and then hit that, and then you constantly be hitting top the world.
But what you could do is you could use your policies and the soft reference as a second strategy. Fallback.
Yep. So all that stuff works. So that can all definitely work, and if that's what people want to do, they can use that. It just It just turns out to be better most of the time to
That is what I
monitor
also
your
get,
hit
because
rate.
if you test your system right, I think your eviction policy should be enough. But so in theory, I could just use the soft reference as a fallback, and the
Yep.
performance shouldn't degrade, because and in most cases the entry should be collected by your strategies or policies, and in worst case, it's going to be the stop the world collection, right? This would work.
Exactly.
You
And
shouldn't
monitoring
rely
the
exclusively on the soft references.
exactly.
This is what I don't get,
Exactly.
because
And
exactly.
that was a learning. That was what Google's Java team originally very much heavily proposed back in the Java 5 days, and then everyone learned why that wasn't a good idea. And then luckily we had figured out how to do concurrent LRUs and the like, and so we could make that no longer primary. So that's there. You can definitely add it as an option, but it's just not one that I personally use very often, because
Yeah.
most of the time you need to give Java enough memory anyways, so you aren't super constrained, so you don't usually have to rely on that. But it's good to have as a fallback for those cases like IoT where you might need it.
And your Caffeine project, do you emit any metrics or monitoring stuff, which is interesting? So can I just get
Yeah, so there's stats that and then there's a bunch of adapters from different, Micrometer, Drop Wizard, Prometheus, a bunch of others. They provide their own adapters to capture those metrics, and
Yeah.
we just publish the basic stats.
So now, it was a vacation project. Then you spend a few hours in train hacking on it,
Yeah.
and then you got a team from Israel, and you have
Great
adapters
team.
or micrometer. So how this happened? I mean, this is just crazy, So in a shortest amount of time, you created something interesting, and you are working together with researchers. So how you got the attention, or what was it?
Well, I would say I started in 2008, back when I was just doing it for fun, to learn how to do concurrency.
Okay.
And so, and then it wasn't until 2014 or whenever I started Caffeine. So there was a good chunk of time where I'd done this stuff with other people.
Oh,
I
okay.
learned when I was at Google. I'd worked with the Guava guys who were great, and we figured out how to do the Guava's cache. So it wasn't as if I just woke up one day and I just started from scratch, not knowing anything. And but I built. But the research guys have been really wonderful, because they published a conference paper on their ideas, and I just emailed them, and that's all it took. And I just emailed them, asked them about their stuff. They helped me building up a little prototype in the simulator, so I'd really cache simulator, so I could try all these different eviction policies. And I tried some of them in the past, but I'd always kind of papers kind of tend to lie. If you read research papers, they always tell you the best things and not the reality. So I wrote a simulator so I could try out all different policies and see how what actually worked and how well. And so the researchers, they'd been really nice. They'd helped just fix up my version of their TinyLFU algorithm. And then I found problems, as one would expect, where it's integrated in certain cases. And then brainstorming with them, I kind of figured out solutions, just looking at different workloads and stuff. And so then we would refine those together. They published 2 papers that they were nice enough to throw me as a co-author on, and they do the research angle. But it was just you just send emails. It's just like anything else. I'm talking to a guy who's working on a cache for CockroachDB, which is in Go,
Yeah.
and we're just sending over emails, and we're figuring out algorithms, because he's using an algorithm called Clock Pro, and we're finding degradations, and we're coming up with ideas of how to improve it. And I don't even think he works for CockroachDB. I think he uses it at work, and he thought it would be fun, so he wanted to rewrite their cache.
Yeah.
And then one of their guys had tagged me, and then then I'm just talking to this guy, I think in Korea, and we're just sending emails and coming up with ideas, and he's writing the simulator code, and we're finding ways to improve that algorithm to be competitive with Caffeine. But it's a Go project. When he ports it over back to Go, so it just a lot of people are very friendly. A lot of people want to talk text, and you send an email, and you don't have any expectations, and you just send emails, you send back and forth, you learn from each other, and that's it.
Yeah. ConcurrentDB, by the way, is a crazy project. It's a really nice one, right? It's incredible what they are doing. Are you aware also of MapDB project? MapDB, you heard about that?
MapDB. Oh yeah, MapDB. I think I talked to the author a long time ago. I forget his name off the top of my head, but yeah, he was a great guy. I know that was like a persistent.
Yeah,
He was trying to do a
because
persistent.
you said with the maker, and he has almost the same API to create a persistent hash map. So it's like DB from whatever, and then you create a map back, and if you interact with the map, you get persistence hash map, which remind me of Caffeine. By the way, you know how I found Caffeine?
Oh yeah.
You know why? How?
No, how you find it?
So I use a lot of Jakarta microprofile, and there's a nice project called Quarkus.
Oh yes, of course.
Yeah, and then I use then I take a look at the cache annotations, and I was pretty convinced that they will use Infinispan because Quarkus is Red Hat, and I was pretty sure it's Infinispan, but it wasn't. And I asked them, what are you using? And they say Caffeine. So what is Caffeine? Caffeine? I never heard about that. So a nice cache. We use Caffeine. It's really nice. And I took a look, and then I found you. It's like crazy. Caffeine. How? And then I dropped you a mail. And they say, of course, we can talk immediately. I say, okay, nice. Where are you from? And it's like, yeah, okay, you're from USA. Okay, this can be challenging with the time zone. And now we are talking. And even crazier. So if you have your stack with REST Easy, Juice, you have almost Quarkus. I don't know whether you're aware of it. If you if you use Quarkus, actually, what could happen is that Quarkus will consume less memory than your combination of Jetty, JAX-RS, Juice. This is what you should investigate, because what I did in my projects is I compared Quarkus apps to empty Jetty or Tomcat, and Quarkus was smaller.
Yep, I think and the Quarkus guys are pretty great, and the Infinispan, they used to use their own cache, but they didn't. They switched over to Caffeine because they had bugs, and why maintain it if someone else will do the work for you?
Yeah.
So the Infinispan is now on top of Caffeine. It's for its local cache as well.
Oh, I didn't know that. So Infinispan uses Caffeine.
Yeah, they switched over. They had their own. They tried rewriting it. They had a lot of bugs. I showed them that their benchmark was wrong, and in fact, they actually decreased performance, not increased it, because it's very hard to write a good benchmark, right? And so they accidentally wrote the benchmark wrong, and it gave them the wrong metrics. And I was like, here you guys go, just so you know. And I got this project, and why are we wasting our time? Let's just use this.
Yeah.
So they were nice, and they just switched over a couple years back, and then and I guess that's how Quarkus got aware. And I've looked at Quarkus. It looks neat. I guess you probably remember back in the day when you have to just fight with so many different frameworks.
Yeah.
I got very much in the mentality of if you have to use a framework as like a library.
Yeah.
I don't want to live in an ecosystem where I'm dependent on someone else who never thought about my use case, and therefore doesn't give me the flexibility to solve my problems.
Okay.
And I need to get them to do a change, and I have to wait for their releases. If I use it like a library, then I have all the flexibility I need. I can always adapt it. I can always patch because I'm wrapping their work around mine.
Yeah.
In mind. So that's why I didn't use a pre-made stack for like this web server, all of that type of stuff. I just wired it up together for Juice and REST Easy. It's not that hard to do, and therefore, as I needed more features, as I needed to deal with bugs, I could deal with it, and I could also upstream any fixes or issues that I found. And I think Quark is a lot better, but I'm sure a lot of us have suffered at some jobs where we've had the framework help, and so not knowing enough about the Quarkus angle towards things, I do like the ability to say, in the end of the day, I need to get my job done. I don't care if I'm in Eclipse, I'm in Visual Code. Like if my IDE isn't working, I'm just going to go right back to text editor. I'm going to go back to command line to go build. If I can't build in my IDE, I want to get things done. And it used to be in the old days you suffered when you couldn't do that. And so I definitely think Quarkus is probably the future, but that's probably my only real bias against using a pre-made stack. But other than that, I think the stuff that they've been doing, that Micronaut and that others have been doing in this space have been really excellent. And so I'm sure I enjoy working with them if I had the opportunity.
I'm almost similar opinion to yours. The difference is I'm working as a consultant, and I see more project at the same time. And what I really enjoy is the fact that sometimes, like for instance, Microprofile or similar project called Helidon or Open Liberty, Tomcat, Tommy, Whitefly, they all commit to use the Microprofile. So I get exactly the same APIs. I don't care actually about the implementation. So, I could just pick Quarkus and do my project. And if my client is not happy, it's okay, then don't talk to Red Hat. Now come to Oracle. We can use Helidon. And you have exactly the same experience. So and actually, we have the same reasons to behave differently. Yeah. So you like, to patch the library in worst case. What I would do, I would switch the environment. If I get some problem with Quarkus, I would say I would try Helidon. If Helidon doesn't work, I have 5 runtimes where I can pick and choose. And also, my projects are not that demanding or crazy. They are less boring. So it's absolutely okay to give with 80%. I don't have to tweak the rest easy or the jersey, the last bits. I'm just happy if it works everything together. And usually,
do you own the project long term, or do you own the project only for a short term during your consultation?
I'm a short term, but my clients want support from me longer term. So some clients I see every 5 years. So what I suggest them should work in a few years. But they were happy with the strategy so far. And our strategy was rely on the API and not on the runtime. So actually opposite to your strategy, but it worked well. And for instance, in my project, I would do code review and I will find a dependency on Jersey with a defect. Because in the past, we burned on it. There was at the beginning, it was ComSun Jersey, then it was all Glassfish Jersey. And I just would like to have Java XRS, and I don't care what's behind, for instance, right? And so there's a little bit different. And also, if you do it from scratch, you can optimize more, but you need more time. With my strategy, I can go, and I get also fresh developers. Like, look, Quarkus is well documented, start with it. And just implement the first use case, and they don't need my expertise. They can just, create the first CRUD stuff. If you would start with a perfect environment, as in your startup, you will at least spend 2 days, or 3 days with the initial setup. I will have the next problem is politics. If I come in and say, okay, use REST easy, they will ask me, why not Jersey? If I pick Jersey, why not Apache CXF or whatever? So whatever you do is wrong. But if you say, this is the API, just pick it and choose whatever runtime you like. So this was my no politics strategy,
I think that's good. I think the difference is, while I do very much believe use API, like if I'm just saying use JAX-RS, most people don't have to care that we're using REST easy, not Jersey.
Yeah.
And I agree that in your world you can switch mostly because you're going to a different role, or if there's something else. But in your working it day to day, 2 or 3 days isn't that big of a commitment to spend just to set up
you're right.
the role. And then after that, you run into production issues. Like I had to escalate a hash denial of service attack to Red Hat because basically it was hurting our production. We were actually DOSing ourselves because we just changed a route and we ran into this problem. And so okay, I now need to go safeguard my system, go through their security process, get that stuff escalated, show them examples, all that type of stuff. And if I'm using an opaque framework, which yes, if it's using standard APIs, that's wonderful. But if it's opaque where I can't get into the guts, then I can't go off and try to patch and get my stuff working while I'm waiting to get the bug fixed upstream. And so there's a lot of those that happen in day-to-day real world and of a long-term job. So I very much agree. You want to use standard APIs as much as possible. Don't get into the gory details. But back when you used to have opaque, opinionated frameworks that were really not letting you get into those details of things, and nowadays modern Java is a lot better, is more library oriented, not this massive framework. Then being able to say, I need to get my job done. I need to make this work. I can't wait 2 or 3 months for trying to convince some developer maybe to make their patches. Let me make sure my stuff will work. Let me upstream what I can. Let me work around their issues, and then I'll try to remove whatever workaround I have when the official system is ready. Yeah. And that's something easier to do when you're taking the more library oriented. But like I said, nowadays modern Java is a lot better than it used to be. Back in the early 2000s, it was pretty awful in that respect.
The problem is also no politics in my project. Sometimes companies would like to have support, commercial support. So we need both. If there is something problematic, we have to patch it and then wait until the vendor, accept the patches or patches for us and they get the official release. Because if you just fix the problem on your side, you created basically a fork. So if they release a new so this, but I really enjoyed, your perspective.
But at the same time, it doesn't have to be a fork. I almost never have to fork a project to fix a bug because if the project is more like a library, I can kind of wrap those and tweak those internals without forking it. Because oftentimes there's a little bit where there's a hook somewhere that I can still get into it. I don't, so only very rarely do I fork a project and suffer that, and I try to get rid of that as soon as
Yeah,
possible.
you should if you are able, to contribute the patches, it works.
Exactly.
But the problem is, with my clients, the larger companies, they not always run the recent version of the version, and then it's really hard to convince the open source developers to patch an old stuff, or this is a little bit. But I really enjoyed your point of view. So now, where people can find you and your Caffeine, do you have and some pointers to your Twitter account, to Caffeine or whatever?
You just search on GitHub. It's you just do a Google search for Caffeine Cache, and you'll find my GitHub, and it'll just be under GitHub /Ben-Maness /Caffeine. But honestly, Google is a lot easier than anything else. And then there's a wiki that is based off Google's user guide that's been updated, that has all the details on it. Other than that, you can open up issues. You can post on Stack Overflow. You can email me any questions. I'm happy to help them. Like I said, like a lot of times, like you said, us just talking, it was just people sending emails, and you have interesting conversations, and that's what makes the job fun.
Yeah, it was really fun. It was a talk with you, So just out of a blue, I sent you an email, and now we are talking. So beautiful Java world, I would say, right?
Yeah, thanks a lot.
Yeah, thank you a lot.